Hey everyone, welcome back to 30 Days of Python Challenge. It's day 11 and we are focusing on functions. Think of functions as a reference to the code you want. With it, you write code once and you reuse it over again. This is key to writing clean, maintainable code. Hopefully by the end of this video, you will have understood what functions are and how to use it effectively. In programming, a function is a reusable block of code that would be performing a specific function. Like I said, think of it as a reference. You are using the code to prove a point, and functions is your way of referencing that code. Take a look at this. Without functions, we are going line by line to execute code that is similar over and over again. So, functions are like references to an article. You won't write out a whole article or journal again if you want to reference a passage or some data from that article or journal, right? Once a function is defined, it can be called once you need it. Let's create a function. In Python, we use the keyword def to define a function. The basics in defining a blank function with no parameters. You can then call the function with the open parentheses. If you include parameters, you should also include arguments when calling the function. In this function, we're printing the name, which is the parameters of the function. When calling the function, the argument will be a string or an integer or float, as we haven't specified the type of parameters needed. So in this case, we're calling the names we specify, like Alice and Bob. So you can see a pattern building here, right? Define the function with parameters and then indent it, the code. Outside of the defining block, you can then call the function. It's best practice to leave comments on what the function does within the defined function. Let's make these functions flexible. Parameters are like placeholders that get filled with actual values when you call the function. In this example, we can see the use of multiple parameters. We call it in chronological order as seen here. If we specify using the keywords when calling the function, we don't need order. We can also create custom arguments for parameters like this, greeting. In the second call function, you can see we change the greeting parameter. By default, it's hello. But if we changed it by changing the function argument of the parameter greeting, it will override. To make more flexible arguments, we use the asterisk. This means it will take all arguments and use it in the function's code. Functions aren't just for printing. We can use the return statement to give back the value of the computed function. Like this example. In the function add numbers, we return result variable. For the argument, the parameters a and b are used and the variable sum result in is used to add two values. The sum result is used as a placeholder for the output of the function when the result is returned. With multiple return values, we can see that we can return multiple results like area and perimeter. When calling the function, specify the variable to store the results in, like we learned earlier in the series. We can check for booleans, like this example, for returning output early. In this example, we use the conditional check and return the string invalid age for the incorrect input. So we can see how return statements are a function to communicate results back to the caller. That can be multiple values as a tuple. Now let's talk about scope. Which variables can be seen where? This is crucial for avoiding bugs. I've recently been a victim of my own faults regarding this very issue. Let's take a look at this example. We have a variable called global variable that will be used by everything. We then declare a function, demonstrate scope. Inside this function, we have variables that can only be manipulated inside the current function it's in. To modify the global variable, you use the keywords global to do so. The second example does not consist of the global variable. As you can see, it returns the variable count. When calling the function, the output will be 1 or not 2, since the variable stores and returns within the function rather than being available outside the function. Therefore, it will always return 1. So the rule is quite simple. A variable defined inside a function are local and can't be accessed outside. Variables defined outside of a function are global variables. To be used inside the function, you must use the word global. Python has another function called lambda, which takes small anonymous functions defined in a single line. Like this example, we declare a normal function with lambda. We can do this in one line. The exact same code. You can also do multiple parameters with lambda functions just like normal functions. Now for some practical use cases. Take the dictionary variable people. You can sort the dictionary by age. Lambda are perfect for short, simple operations. And when you need a quick function as an argument to other functions like sorted and map. Documentation and clearly named variables are important. Good practice is being descriptive in naming, keeping functions small and focused, using docstring, using return statement rather than printing, and use the type hints. A good sign of good functions are good documentation and predictable behavior. And that's that for functions. It gives you the ability for you to write modular, reusable, and maintainable code. On day 12, we will be looking at modules, learning how to organize our functions across multiple files, use Python's built-in modules, and even create our own. I will see you then. Cheers for now. And please do leave a like and subscribe if you are finding this type of content useful or helpful for you in any case. Thanks. Cheers, guys.